So our next talk is one that I'm particularly interested in, actually, which I'm quite excited for. We haven't got the name of it up on the screen, and I'll let you give the name of the talk for those of you who haven't looked at your schedules or anything like that. We've got Premshree, and you are a senior engineer at Etsy US. You've been there for a few years now, 4 years,
Yeah.
as I understand. And you've worked with Yahoo on several products that they've got live, 360, so on and so forth. But more important than that, you've got a few other hobbies, photography, I understand, cooking, all that sort of stuff. So yeah, that's really cool. What do they say? Man of many talents, really. So Premshree, come and enlighten us to some cool information. Thank you.
Thanks. I have to say I'm only mildly surprised that I heard the word hangover so many times this morning. So that's me. I'm a senior engineer at Etsy. I used to be at Yahoo. I like to say it's because it's a PHP conference. I have mildly followed into Rasmus's footsteps, except I do not know anything about what he does, really, on the internals. So just to give you an outline of the agenda, I think I'll talk a little bit about Etsy, a little bit about the shipping team at Etsy, and then we'll go into the tracking architecture. We'll talk about a little bit about monitoring and finish up with some Q&A. So I was curious, so I haven't told you exactly what I'm talking about yet, but I think it'll be cool if the stuff I'm going to talk about is a general class of problems that have a very similar solution. So while I'm speaking about it and you guys have ideas on how you might do this differently or how you might make it better, I think what's cool is you guys all have a little notepad that the conference gave out yesterday. So if you have ideas, jot them down, tweet it to me, or come talk to me later. I think it'll be fun to discuss everyone's ideas. So I want to talk about Etsy a little bit because I think it's important to understand what you're actually trying to solve, and I think without having empathy towards the users, the specific problems you're solving, there's no way to come up with a solution that's optimal given developer time and also actually coming up with a solution that works for people. So Etsy, how many of you have heard of Etsy here? Okay, I guess pretty much everyone, most of y'all. So the larger goal of Etsy is to create an economy where it's a fairer economy, and I think a lot of cities around the world are moving towards that kind of an economy already. So to give you an example or a real life comparison, Etsy, in some ways, Etsy is like the online version of what you might see like at a craft fair or a market. So this is a small little market I went to in Cleveland, Ohio, where there are people selling all kinds of handmade leather bags, a lot of ceramic, and also, of course, a lot of food. There's a little market in Hong Kong that I went to. It's a Sai Kung Sunday market where a lot of local people from the area in Hong Kong, and especially, not surprisingly, a lot of Australian expats who live there sell their stuff. They also sell a lot of Australian food things that they, I think, miss when they're in Hong Kong. So this was a seller, actually. She's originally Australian, but she was selling her bags in this market, and she also happens to be an Etsy seller. This another example of a market. This was in Zagreb, Croatia. So in many ways, Etsy is like an amalgamation of all these little markets where people are selling all kinds of things, cat houses, scarves, and I think most of you know what's in there. I love pottery, and I often try and get ceramics from wherever I'm traveling. So for example, if you do a simple search, a sample search might look like this. This very organic little organic plates. These are from Scottsdale, Arizona. These rustic-looking ones from Andover in Massachusetts, and a coffee cup from Greece. So I think it's important for me when I'm solving problems to understand the scope of how it affects different users and sellers. And I think it's very cool to see people from all over the world putting so much energy into what they're doing. And I think that helps you extrapolate how you might solve that problem in a more empathic manner. So Etsy right now has around 1.4 million active sellers from all over the world, 19.8 million buyers, and around a little less than 30 million listings. So I work with the shipping team on Etsy, and I think a lot of people who do not work with a company at that scale often wonder, what does a shipping team do? And so I thought it would be useful to just spend a couple minutes telling that. So this is actually some of my team, and we don't pack boxes and ship them, but we did go on like a little offsite like thing where we tried to be buyers and sellers, and we actually shipped empty boxes to each other through the postal service just to simulate how it might be to be a seller or a buyer and see where potential problems are. So we do a lot of different things on the shipping team. This is actually in Italian. So this is an example of what a seller might send when they have shipped a package to a buyer. They want to send a shipping notification saying your package has been shipped. You can add a tracking number, etc. We also have tools for pricing postages. Sellers really need tools in order to optimize the way they send packages to buyers. So something that sellers always want is how do you price your postage? We also allow sellers to print labels on our site. We right now allow sellers in the US to print shipping labels using USPS directly from Etsy, and also in Canada using Canada Post. So, so tracking. So this is the topic of our conversation today. And while it's specific to tracking, I think, like I said before, it solves a general class of problems that have basically essentially a solution that's in the same vein. So everyone knows what tracking looks like. You go to a page and you want to see where your package is at any given time. So what we're trying to solve is just that. Where is my package? So at Etsy, at any given time, there's around 200,000 packages in transit, and that's not through the day. It's any 15-minute window. There's 200,000 packages on the way somewhere to some buyer. There are around 125,000 packages out for delivery at any given time. Again, like a 15 or half an hour interval. And there are packages shipped using over 150. I think it's probably closer to 200 carriers now. So by shipping carriers, I mean the usual, like FedEx, DHL, UPS, Australian Post, Belgian Post, all those different carriers. So, so the way we store information, the tracking information itself, we store is in a denormalized MySQL table. And this is a slightly simplistic version of what we actually have, but just for illustration purposes. All the tracking information is stored at the shop level. So we have the shop ID, tracking ID that's like the primary key where the different tracking codes are stored. The tracking state is what you saw that the end state is. So we don't store every state of a given package. We store the last state of a given package in this particular table. And the tracking code is a unique code generated by each carrier. Now you'll also notice there's a field called shipping provider. We need that because it's not necessarily guaranteed that a tracking code would be unique across carriers, so we can't rely on that being a key. Last access date and queue, we'll come to that in a bit. So like I said, we only stored the last state information for any table, for any package in that table. But there are a lot of events, and we store each of those events in a separate table called tracking events. It's a similar table to the tracking table itself, with all the information for any given tracking code, but I'll not go into that. So shipping APIs. So how do we actually get this information? You'll be surprised happily to know that a lot of carriers actually have an XML or some form of REST API in order to get information for tracking. So in this case, this is actually USPS's API URL. So you just pass it the tracking code to get tracking information. And also, incredibly, a lot of the times you do get RESTful responses. So this is actually a response, or well-formatted XML responses. This is a response for a tracking request for USPS. You'll notice the responses always have the details of the tracking. The things like the event time, event date, where the event occurred, and also just the event time is always going to be local to where the package was where the package was in at that given time. So you'll notice, pay attention to the event. It says arrived at USPS origin facility. Now tracking states. Now there are going to be a lot of different events for each different package, and each different carrier has its own way of defining what an event is. This is specific to USPS. What you see here, depart USPS sort facility. FedEx is going to have something else. And notice the markers around on the top. Those are the different events that you really care about. So there are a lot of different events, but they eventually mean one of these states. So a package is either shipped, or it's in transit, or it's out for delivery, and it's delivered. Those are the primary states that we care about as a buyer when we look at it. Is my package in transit right now? Yes, no. You probably don't care about this specific event. So what we do is we map each of these different events from each carrier to one of those events. So, because each carrier, there is no standardization amongst different carriers as to what an event means. So we create our own abstraction for the various events that we map into one of these states. So for example, info received is when someone has printed a shipping label, and so potentially the postal service carrier has received information about it. That's an info received state. In transit could be one of those many states where it's in a sort facility, or it's in the truck. So the state map is what we use to map the various specific events to one of these states. So for example, an event that USPS returns as accepted at USPS sort facility, picked up, is mapped into our system as an event called info received. So this is the same. These are the same events for a different carrier. This is for FedEx. So in FedEx possession and are picked up, these get mapped to the same event in info received. Similarly, we have various mappings for in transit. Now the very basic, simplistic way of trying to update tracking information at any given time is basically do a select from the table and then get all the rows and then make API calls for each of those. And that could be potentially run on a cron, select everything that hasn't been updated in 15 minutes or half an hour. So that's just an illustration of what it is. A cron that makes a request to the database, runs that query, and then we query each of the APIs. The problem with that, of course, is that there's going to be a lot of rows, and it's unpredictable how many rows you're going to get out of the system. So the other solution for that would be to limit the number of rows. And limiting is OK because you're going to run that cron very frequently. So chances are you're not going to miss out on a lot. However, you're still going to have a lot of stragglers. So what that means is your query is going to run so that if your table is very tall, chances are you're going to miss out on a few remaining trackings every single time you run the query. And the only way to update that would be to have another cron run to pick up those that haven't been picked up. So, so let's talk about sharding. How many of you are familiar with sharding? Quite a few. So I'll just give a quick rundown on sharding. It's, in order to understand sharding, it's very important to understand the context in which you want to shard, and that depends on your particular use case, your particular website. So in this case, in the case of Etsy, we primarily have two kinds of objects, we have like a shop, seller shop. There's a seller's completed orders, and we have a user and my purchases. So at Etsy, we primarily shard things based on a user and a shop. So when you want to shard something, the idea here is you can't, considering we have around 1.5 million almost active sellers, that would, if we were to store every shop information in one large table, that would mean a table that's 1.4 million tall. That's not going to scale. So the very simplistic way of sharding is to have one index table that's very tall, but that's also very narrow, that has exactly two things. It has information, it has user ID, whatever the key you want to shard on is, and it tells you which shard to look up information in for that particular user. So that means you have a very, very small table, but it's very tall, but it's very easy to access that table because it's very quick. There's not a lot of data in there. And then, so in this case, so if you want to say, if I want to get information about a user X, I go into this table, I ask, where is user X's shard located, find that information, go to shard X, and get all the other information. So that means your data is distributed amongst many different databases. So that's an illustration of how it would look like for a user. Whenever you want to fetch any user information, you go to the index table, ask where this user's information is located, go to the shard, fetch information. Similarly for the shops. So one way to optimize this would be to shard tracking, and we could shard that using shop as a key. And so when you optimize the query, if you introduce the shard, you're making sure that you reduce the number of rows returned by a lot. I don't know the exact number of shards we have now, but a very basic way of doing sharding is to do a modulo operator and then shard it that way. But we do something else, and we do logical sharding, and so the number of shards, the physical boxes can vary, but from the application abstraction layer, it's always the same, and we don't have to care about where to fetch information from. So this ensures that if you had one box that you were fetching 100,000 rows from, and now you shard it to, say, 25, you're reducing the number of rows returned by a lot, and which eliminates the need for having a limit. So in this new situation, this is how the architecture kind of looks like, where there is a cron, it's continually running, and for each shard in your system, it runs a query saying, give me all the rows for this shard for tracking rows that haven't been updated. And then you get those rows back, and then you go make API requests to update those rows. So queue, it's not a real queue because it's just a notion. It's a different key we are introducing into the system. So like I said showed in the SQL before, we have a column called column called queue. Basically, we map every tracking row into one of 5 or 6 different types of queues, and these queues can be changed depending on your situation. What that means is when a package has just been, when a shipping label has just been printed, chances of that tracking code being updated anytime soon is very low. So anything that's in a state called info received, we map it to a one-day queue. What that means is this tracking code does not need to be updated needs to be updated only in another day. Whereas something that's out for delivery probably needs more frequent updates. So anything that's considered out for delivery gets mapped to a 1-hour queue. And so we make requests every hour for that particular tracking code. Anything that gets delivered, it's surprising this happens, but sometimes we do see tracking code that reach a state of not found or lost. It happens very rarely, but it happens. And so we stop tracking packages at that point. And also the queue maps are variable. We employ a lot of A/B testing, so we can say for 50% of the users, let's use this map, whereas for 20% of the users, let's use another map. And we do that only to see what's more optimal. Because the problem we have here is we have to balance how many requests, API requests we make, because we don't want to get rate limited by the APIs. But at the same time, we also want to have packages be updated as frequently as possible. It's incredibly not surprising, but it's amazing that people really care about knowing exactly where their package is at any given time. And if they don't know, it drives them crazy. So queue age. So like I said before, what a one-day queue means is that if a package hasn't been updated in 1 day, it needs an update. If a package hasn't been updated in 3 hours, it needs an update. So these are all very user-definable queue ages, and we map them to whatever age is appropriate. So in this case, it's obvious. A 3-day queue is 3 days. It could be something else, a half-day queue. So now it becomes even more refined, where the query becomes select star from the tracking table, where the queue is whatever you're querying for, and the last access date is less than the age. So that's basically saying what I said. Get me all tracking from this shard and this queue that haven't been updated in the last 1 day or 3 hours or 1 hour. So I think Chris talked about a lot about async PHP yesterday, and we use Gearman a lot to do these kinds of processing. I won't go into that because a lot of you probably know about it, or at least do now after Chris's talk. And we also whenever we run a Gearman, we have an abstraction over Gearman, and then also Gearman allows you to run jobs so that you can have a unique key, and the unique key we use is shard and queue. So what that means is each time you run a Gearman job, if there is already a Gearman job running for a given shard and queue combination, we don't spawn another process until that is done. So that means you're not, we use Gearman for a lot of things outside of tracking within Etsy. So it means we are not overwhelming the system with a million Gearman jobs. Also, it's worth pointing out that the nice thing about having it be asynchronous, and also because it's in nature, it's a cron that's running, it means it's self-healing. If you kill a Gearman job, it's fine. You run it again, it will pick up packages that were missed from getting updated. So in this, including the changes that we introduced with Gearman and the queue, this is what the architecture looks like a little bit. It's a cron that runs every 5 minutes that spawns off a Gearman manager, which spawns off n workers. Each worker is for a combination of each shard and queue. And then we make each of the workers make requests to the API, gets the data back, and puts it back to the database. So it's a very self-healing system. Anyone got any questions so far? Can you wait for the mic, please? Thanks.
With the tracking events, do you optimize it for geographic location, or do you just ping any API? So it could be any cron job could just ping anywhere in the world, or you try and break it so you only ping FedEx from one location and whatever Australia Post from another and Royal Mail from somewhere else?
Yeah. So with the I'm not sure I fully follow, but maybe I might answer your question. For each tracking code, we know the tracking provider already, so we know that this is a FedEx package. So we only have to make a request to FedEx. The only problem happens when it's international packages.
But what I mean is when you're with these cron jobs, when they're hitting the APIs, those APIs are for any mail provider that you deal with anywhere in the world. So you don't optimize based on that.
It's for. I'm not sure I understand. It works with any tracking provider in the world. Yes.
I think he's
But
referring to latency.
well, we can't optimize on that because right now our boxes are located only in one location. So even if we wanted to, we can't. But that's a good point. I'll just to quickly summarize what we talked about. So we have a lot of the carriers have an API. It's sometimes challenging to deal with some of these because, for example, I think DHL in Germany, there are some other examples, but they require you to, some of them require you to enter additional information that cannot be passed in through the APIs, so it's kind of moot. We use a state map to map the different events that the various providers return to what makes sense because there's no standardization across carriers. We use sharding a lot, which helps scale much more easily, and we use a combination of cron and async Gearman, and the concept of a full queue. So monitoring, we use statsd. Anyone here heard of statsd? Some of you. Statsd is just it's a very simple system that runs over a socket, UDP socket, where you're constantly sending packets in order to monitor different aspects of your application. Statsd is available on Netsy's GitHub, and I think there are implementations for pretty much every language. So for monitoring, we monitor stats for all the tracking information that we have in our system. We monitor the Gearman worker calls that happen. We also monitor API calls to the various providers to make sure we are not going to be rate limited by them. And we also have Nagios alerts on all of these. So I'm just going to run you through some graphs. So it's not, I guess it's not important what you see here, but there's a pattern and it looks okay, so things are okay. And if you notice near the end there's a slight dip. This is basically a graph of the number of tracking packages being tracked every single day. Near the end, that's the weekend, and there aren't that many packages during the weekend. This is a not very nice looking graph of the batch requests we make to update tracking. These are essentially the Gearman manager calls that spawn off various worker calls. This graph doesn't look very good, but there is nothing unusual, so we know things are okay. So this is for USPS. We do it for every major provider that we have. So this is for Canada Post, for example. We also monitor curl errors. That's another way we know when something's going wrong. These are the curl errors for FedEx. We also monitor tracking calls by providers. So like how many tracking calls we're making for each different provider. So USPS. Callers for USPS. So, I think it's the easiest question to ask is why not ActiveMQ or RabbitMQ? I think that's a very fair question, and the only reason is we started off implementing this when we started off even working on having tracking be possible on the site, we didn't think it was a big problem, and we didn't think people cared. And so our solution was very simple and naive to begin with in the start. But soon we learned people deeply cared, and we had to move from what we had at that point, which was a very simplistic cron. So we just evolved it that way. But a very efficient, easy way to replace the cron aspect of it would probably be having a real queue. Webhooks, how many of you have heard of webhooks? I think webhooks would be ideal for this if every carrier actually provided that. Unfortunately, almost no one does. I think there were a couple of postal carriers that allow it. It's essentially if the API could tell us, hey, we have an update, and push things onto us instead of us polling constantly. Yeah. Mm-hmm. So that would be far more efficient because we don't have to constantly poll to check. I don't know if you guys have ideas, but can someone bring the mic here, please?
Hi.
Hi.
We do tracking in our system, and the way we work is we get a CSV from the tracking provider, say every 15 minutes, and pull all of their event data down, and then process that. Is there a reason you don't do that? And would you say, using queues is more efficient? I guess because, yes, if you only check once a day for certain events, so yeah, is there a reason that you do, I guess, requests from APIs for each customer and their package rather than grabbing all data?
Yeah, is this USPS or?
No, Australia Post and DHL.
Okay, because I know the reason we did that was only because not every postal service allows for that, where you can get I think USPS allows for where you can send them a request and get information for a bunch of tracking codes. However, the other problem is sellers on Etsy are independent sellers. We don't own the packages. So we can't, I don't know that there is a way for us to say, here are a bunch of tracking codes that we own, give us information for it at the end of the day. But what we found is using a queue works quite efficiently because there are many packages that don't need to be tracked every day, especially if they're international. And yeah, I think that's the only reason.
Cool. Thank you.
Any other ideas? Anyone want to share?
Hi there. I've actually got a question relating to finding information in particular tables. So when you have the lookup table and you want to find a particular user, it makes it nice and quick to find that user in one of your sharded tables or databases. But how do you deal with the situation where you don't know which tables it's going to be in? Let's say somebody's searching for a particular type of ceramic pot. That could be spread across many of your tables. How do you go about improving, speeding up that situation?
Well, in the cases of, I think the situation where that would happen would be in search. And in search, for example, we don't look up information on the shard. Whereas if you're going on a shop, it's always at the shop level. If you're going to a user's profile, it's always at the user's profile level. So we know it's one or the other. The situations where that arise are search, or if we were to suggest similar listings, and those are not information that is fetched from the shard. That's always fetched from the search index is a separate index. And also we heavily use memcache to cache a lot of data. So yeah, we just don't go to the shards for that. There are situations where sometimes we need that kind of information where we have to fetch information from various shards. And many of those situations, fortunately, are in the background are asynchronous. So we just do find on all shards.
Thank you.
Sure.
Retention policy for items that have been delivered? Do you keep that data? Do you keep it for X amount of period? Do you archive it?
That's a good question. I believe we delete it after 3 months, but that's fairly arbitrary.
How many servers have you got running these cron jobs, or the Gearman side of it? And with, I guess, 200 APIs that you're queuing, how do you deal with faults in those APIs or very high, unusually high latency levels?
So your first question, I don't know the answer because I think our hardware ecosystem is constantly evolving. So I honestly don't have an answer to give you. As for faults, we heavily log things, and we use Logstash to detect any problems or latency issues. There are in one of the graphs I showed, and we have many more graphs where we detect HTTP error codes, and that normally shows up. Like connection errors show up pretty quickly.
Have you got someone monitoring those kind of constantly, or do you just?
We have a robot monitoring it. We use Nagios. So we've tuned our thresholds such that it's optimal for us where there is a problem, and when something falls below the threshold, we get an alert.
Premshree, what's your procedure from over here? What's your procedure for making the decision when to add another shard, and do you rebalance, or do you just simply wait for the new ones to fill up?
So the sharding at Etsy is there's automatic rebalancing that happens, and that's completely transparent to the application. I don't know the details of the core that happens for the sharding, but the application doesn't need to know. The rebalancing happens. So also, I guess it helps to tell. So we have, for each shard, we have two sides. So we have side A, side B. So when the rebalancing happens, we pull out one side and then rely just on the other side. And then we rebalance the shards on one side, and then we put that side back on, pull this out, replicate, and put them both back on. So there is some mechanism to it, but it's not based on when a shard gets full. Go ahead.
Hi, for all these 150, 200 different APIs you're requesting, do you use PHP programs to make those requests? And do you have some sort of framework that you use, internal or external, to help you?
We use PHP. Most of our application layer logic is PHP. We don't have, I guess like when you said framework, did you mean?
There might be some frameworks out there that help with writing general purpose scrapers or grab, frameworks that help you grab data from APIs in some way that.
No, so most of the carriers we have most of the carriers we query have a proper API. So we have a REST abstraction layer, if that's what you mean, but we don't have a bigger we don't have a very big framework that we use in order to make these things happen.
Okay, yeah, that's fine.
Any other questions?
I'm assuming the problem you're struggling with is that you'd rather do CPU work as opposed to curl requests for network traffic and smashing the servers as often as you are. So if that is the problem, have you guys ever considered like pattern recognition? Like say you're having 200,000 packages shipped from here to here. It happens every weekend, but you know that you don't get any requests over that weekend, so you won't check. Or do you do anything like pattern recognition to avoid extra curl requests? Or anything
That's a great question. We did consider that, but for now, so to give you a rough idea on the numbers, like every worker processes around 38 or not more than 200 API requests at any given time. So that multiplied by how many of our workers, which really is not relevant. So we did consider doing that, but it's not a problem for now. So I think it's a lot of work for very little gain for now. I have 1 minute. Any other questions?
I was just wondering the reasoning around storing the shop to shard mappings in a table instead of a key value store or hash map or something like that.
Sis, what was your question, sorry?
So all of your shop to shard mappings, you're saying they're in a very tall table. Just wondering why it was implemented that way instead of.
Well, MySQL is our source of truth, but more often than not, you probably are not going to the table. You're going to get it from cache. So we do have like a cache layer on top, but that's not our source of truth.
Okay.
Cool. Oh, last question.
Just a follow-up, I guess. Do you shard your sharding table? Or do you distribute it, or do you have any mechanisms? I mean, obviously it's going to get too big at some stage.
That's a good question. I don't think yet. We do have sides on the index tables as well, of course. But I guess the answer is no, not right now. All right. Well, if you have any questions, you can tweet to me, or I'm going to be around. But also, I think like every other speaker, I would really appreciate if you could take some time to give feedback. And that's it. Thank you so much.